Hi, my name is Chris Kopacz. This is my final project for CS89 Deep Learning for the fall 2024 semester. The project topic that I chose was image colorization, taking a grayscale image and trying to parse the original colors back onto the image. Um, the methodology that I chose to employ was something similar to a U-Net structure where the first half of the model is the encoder and the second half of the model is a convolutional decoder. Um, the specific implementations that I used replaced the front half of the model with four different structures. Model one is a very simple custom convolutional 2D model that I wrote myself. The second implementation uses VGG19 as the encoder. The third model uses ResNet 50 as the encoder. And the fourth model uses Exception as the pre-trained backbone encoder. Each of the models uses the same decoder. It just takes the output from the encoder and tries to recreate the original image. Um, This is the demonstration code for those models. I'm running on Python 3.10 and TensorFlow 2.10, and I do have a GPU, so it'll run a little bit faster than on CPU. Um, so for each time you run this code, the kernel needs to be restarted, and then you can pick which model, uh, which encoder you want to use. Um, for the project submission, I have to submit a very small data set of only 50 images. The original data set is many gigabytes of images. Um, so if you do download this code, just make sure to select a model, change the number of epochs, and then point to the correct directory of your training data. These are helper functions for training and then making predictions after the model is trained. This is the function for getting the VGG19 backbone. This is the custom model that I wrote. This is ResNet 50, and then this is exception. So based off of which model you selected, it'll call one of those functions and then train the model. Because this is just a short demonstration video, the data set and the epochs are very low, but this is just to show that the model will train. Once training is complete, this cell down below will show the output. Each model takes an original color image, converts it to grayscale, and then makes a prediction. Again, because the epochs in the data set for the project submission are so low right now, the predictions are pretty bad. Um, but if you increase the amount of data that you're using, the predictions get a lot better, as well as increasing the number of training epochs.